so much for coming and viewing our presentation today. We are so excited to tell you about our capstone senior design project of streamlining production capacity of a startup beverage company. Our agenda for today includes a team introduction, a quick company background, our project scope, which will break down into 3 different charters and dive deeper into them, and then we'll go over a quick demo to wrap it all up. We are the Good Vibes Depot team. My name is Paige Roden, and I'm an industrial engineer.
I'm Rachel Millett, and I'm an industrial engineer.
My name is Neubauer, and I'm an industrial engineer.
My name is Bridget Arnesen, and I'm in engineering management.
Our faculty advisors included Dr. Jim Burns and Dr. Tycho Fredericks, and our company sponsors from Good Trade Depot included Amber Johnson and Matt White.
Yeah,
I'm going to pass it off to Bridget to talk a little bit more about the company.
Okay, so to start us off, Good Trade Depot is a beverage co-manufacturer in 3PL located here in Kalamazoo. They were founded in 2020, and then in 2024 moved to a new facility that had a larger brewing capacity. Since then, a major focus has been on the production side of business. So their production process includes batching, canning, shelf stabilizing, as well as labeling and warehousing. So being a beverage co-manufacturer means that Good Trade takes on a client who is looking to scale up their formulation and produce a canned product. There are numerous types of beverages, and there are various material and production options, essentially meaning every production that comes through Good Trade stores looks different. When we began working with Good Trade in the fall, they had just acquired a new piece of equipment. This is the Tunnel of Love. It's a tunnel pasteurizer, which is included in the shelf stabilization portion of production. We immediately had a few questions. How does it work? How does it behave within production? And how is it reflected in pricing and scheduling? In order to dive in further, we need to understand the full functionality of the equipment. We need to understand the settings and how it relates to the throughput. We need to look at production as a whole. We have a good idea that the pasteurizer will be a bottleneck. However, we're not sure exactly how or where. And then finally, we need to determine an accurate throughput to really drive the pricing and scheduling strategies. So using those aspects, our project is organized into 3 major project charters. We're going to start with the pasteurizer. We're going to evaluate those variables and test the equipment settings so that way we can produce a tool for Good Trade to use. Next, we'll look at production as a whole, and that way we can really see where the accumulation behavior lies and get real accurate throughputs for the production, and then be able to use all of those results and findings to improve the pricing and scheduling strategy that Good Trade already uses. A few things to know about our project that pose as both opportunities and constraints. Good Trade Depot is a startup company. We know that is a great opportunity for us, that small changes can have a very big impact. However, we are limited on our resources that are available to us. Good Trade Depot is a small working force. When we started, there was only 2 employees, the owner and the director of engineering. Since then, they've grown to a whopping 4 employees, 1 including myself. So with that limited workforce as a constraint, we know we have the opportunity to really utilize our work design and material handling strategies. And then finally, Good Trade Depot continues to grow every day. So we know we have an opportunity to build those foundational tools that will help grow with the company. However, we do know we have a constraint because we have a lack of ability to really do some data validation, just with sporadic scheduling. And now Rachel will take it from here.
Thank you, Bridget. I'm going to walk us through some helpful vocabulary before the guts of our presentation. So first of all is tunnel pasteurization, shown on the right. It's a conveyor that sprays hot water on these cans to raise their internal temperature, killing harmful microbes and adding value by extending their shelf life. And those microbes are any bacteria, viruses, or fungi that can cause spoilage or disease. And then target temperature is that internal desired temperature to reach to kill those microbes. And then dual with that is the hold time, a continuous hold time to hold at that target temperature, again, killing those microbes. And finally is PU, which stands for pasteurization units. It's a relationship between temperature and time, shown with an example at the bottom, 4 very different variables, all equaling 1 PU. And now I'm going to get us into our first project charter of the pasteurizer. Having a deliverable of a calculator resulting in the desired belt speed percentage in that spray temperature of the pasteurizer, achieving 100% consumer safety. We're going to achieve this by following Plan, Do, Consult, Act, and designing an experiment to define production variables that have an impact on both the internal temperature and that hold time. Getting into the planning stage of this charter, we were able to identify 3 independent variables that have an opportunity to affect the performance of the machine. The first one being can location, with a top-level overview of the cans, labeled A through E, with A being on the very inside and E being on the very outside. Following is belt density, showing 4 different configurations of how cans can be placed together on the belt. And finally is the starting liquid temperature of the product, representing 4 real-life scenarios of how long a product could be outside of a controlled environment, such as the cold room or the canning line. After planning our experiment, we were able to execute it, and I'll be able to walk us through the results. So again, starting with can location, ideally we are looking for these to show conformity, showing consistent processing as that one variable changes. Looking at the graph on the right, there is no conformity. They are scattered throughout, so we're able to identify the worst case scenario visually and through our analysis, deeming location E as the worst case scenario or a testing standard. And that means if we test at location E, we can confirm that there's 100% consumer safety across the rest of the cans. We know this to be true by our p-value of 0, and for reference, any p-value under 0.05 deems it as statistically significant. Following is the belt density. Again, looking at the graph, they are scattered across. We're able to take the least or the worst case scenario, becoming our testing standard of belt density A. And we again know this to be true of a p-value of 0. And finally is the starting liquid temperature. You can again see that this graph is different than the previous two, but following the conformity that we're looking for. So with our analysis in a p-value of 0.82, we can know that there's no statistical difference between these trials, allowing us to rule this out as an impactful variable. After we defined our testing standards, we were able to move forward, creating more data for our final deliverable. With the testing standard, we were able to complete 7 trials, adjusting the belt speed percentage and recording that hold time. Mapping out our trials, we were able to transform the data into a regression model. You can input your desired hold time, and the optimal belt speed is outputted that is also 100% certain of consumer safety. Along with this is that PU equation referenced earlier that we got from industry. And taking us into our final deliverable of this project charter is the pasteurizer calculator. The first part of this is really just administrative details for an operator to enter to keep track of projects. And then reducing their cognitive load, they can enter in the required temperature and hold time. And then the calculator will output the optimal machine settings of belt speed percentage and that spray temperature, along with the attained PU, which is not a machine setting, but gives Good Trade Depot a further insight into how they're processing. And finally, estimated processing times that will be integrated into further charters. And to wrap up the Project Charter 1, again, we went over those standing testing principles that were suggested by the experiment, and we were able to create work instructions for those, along with work instructions for their software utilization to really allow Good Trade to maximize their use of their software while not only collecting but analyzing their data. And finally, insight into industry standards, allowing Good Trade to manipulate temperature and time through that PU calculation. Now I'm going to hand it off to Nate for Project Charter 2.
Thank you, Rachel. So to kick us off for the project charter of production, the main deliverable for this is the canning line, for exactly the estimate throughput of the pasteurizer, as well as the accumulation of cans before the pasteurizer. The main method for this includes a flex sim simulation, as well as validation using time studies, while also following the PDCA principles. So first of all, we made a process map of the overall production here at Good Trade. As you can see to the left, the canning line is able to produce about 40 cans per minute, to where operator 1 takes those cans, puts them in the trays, for operator 2 to take those trays to operator 3. Operator 3 unloads those into rows, loads it into the pasteurizer, where operator 4 takes those cans and puts them in the final goods. And then getting into the planning section for our simulation, we really want to look at 3 main scenarios based off the volume of cans, with the low being 12,000, the medium being 20,000, and then the high being 40,000. With the main validation metrics for that is the throughput of the pasteurizer in cans per minute, as well as the number of cans accumulated before the pasteurizer, or number of work in progress pallets. And then we were also able to verify that the pasteurizer is the bottleneck. We conducted time studies on operator 3 and found that it takes them to load a row on average 15 seconds in comparison to the pasteurizer to create enough space for the next row to go in, is pretty much based off the belt speed percentage. We also noted that around 29% is where the operator 3 turns into the bottleneck. So with the simulation, we really wanted to focus on 29% and below. And then getting into the results of the simulation, we were able to estimate the total amount of time it would take the canning line to produce at those volumes. So for the low, it was about 5 hours. For the medium and high, a little over 8 hours at about 8.33. And then the main deliverable for this, for Good Trade, was the number of pallets before. This is really crucial for them so they could have efficient material handling strategies going forward, as well as for consumer safety, because they need to put these pallets into cold storage so that the beverages don't spoil. And then we were also able to find the estimated cans per minute with this for the pasteurizer. This is also useful for good trade, as it will allow them to develop further future opportunities in terms of material handling. We also wanted to validate our simulation, so we conducted a time study, like I said previously, and we found that in 55 minutes, Good Trade was able to pasteurize about 384 cans, about 7 cans per minute. In comparison to the simulation, we were able to get about 450 cans in 55 minutes, or about 8.2 cans per minute. So some of you might be wondering, why is there a difference? Well, the main reason why that we noted is there's a lack of bottleneck awareness. So operator 3 didn't know that pasteurizer was a bottleneck, and would walk around, look at their phone, do human stuff, pretty much, and they wouldn't really communicate that to others. So with that, there's about a 15% difference from the simulation. And then getting into our final aspect of this charter is we wanted to give Good Trade a recommendation moving forward. So we wanted to add a manual conveyor before the pasteurizer, as well as an accumulation table at the end of the pasteurizer. By adding a manual conveyor before, we're eliminating operator 2, and then by adding an accumulation table at the end of the pasteurizer, it will allow operator 4 to kind of be a flex position, move forward, grab some of those work in progress pallets, and take them to the cold room for future material handling. And I'm gonna hand off the final project charter to Bridget.
Thank you. So for our final project charter, we're gonna take all the results, all the recommendations and the tools that we just gathered from those first 2 charters and really just integrate and apply it to the pricing and scheduling strategies that Good Trade already uses. So here is the current pricing tool that Good Trade uses to price their projects. We're gonna focus in here at the production portion where I'll point out where there's a few inaccuracies. You'll first notice that the pasteurizer required time is the exact same as the canning line. We know, and it's been validated and confirmed in our simulations, that the pasteurizer is the bottleneck, meaning it will always have a value that is higher than the canning line. You'll also notice on this side there is no labor cost attached to the pasteurizer. Again, confirmed in our simulation and our findings, it requires at least 3 operators in order to operate the pasteurizer. So we need to make sure that there is a labor cost associated so Good Trade isn't losing any money. So if they just create those cells to be an independently input cell, we can then use the tools that the pasteurizer calculator created earlier by grabbing the total processing time, rounding up, and using it as the value for the time of the pasteurizer, and make sure that is also reflected in the labor costs. So to summarize the recommendations throughout our project, the use of our pasteurizer calculator not only helps operators easily identify what machine settings they need to set, it also helps Good Trade accurately define the pricing so that way they're making money and not losing any. We definitely recommend incorporating both a manual conveyor and an accumulation table. Knowing that where the stress points are in production, these material handling equipment can really help and alleviate, along with leading into the strategic use of labor, reducing an operator, and also ensuring that there is clear communication with operator 3 about the pressure and bottleneck that occurs there. And with that, Paige is gonna wrap it up with our demo.
Thank you so much, team. So to tie all the dots together, I'm gonna give a quick demo of our drink that most of you have in front of you, Capstone Citrus. So acting as a new company, Good Vibes Depot is interested in creating a new drink called Capstone Citrus, and we're interested in a batch size of roughly 20,000 cans. So we would meet with a food scientist and create a process authority letter, which is on the right, and then after we would fill out the application on the left. The application provides Good Trade with our product variables, such as our beverage type, our volume, and our can size. And then our process authority letter provides Good Trade with pasteurization recommendations that are necessary for consumer safety. Using these variables, Good Trade can go over to the calculator that we provided for them, put the input variables in for the project variables and the input variables, and the calculator will give data-driven recommendations for machine settings. Along with that, and more importantly, the calculator will give us estimated processing times. So given our PA letter said a hold time of 10 minutes at a target temperature of 160 degrees Fahrenheit, our calculator estimated that the processing time is going to be 15.69 hours. Using that, Good Trade can go over into their pricing and scheduling tool, and they will be able to round that number up to 16 and put in for machine hours and labor hours, which will then allow them to accurately quote us a production cost of $1,957 for our project. Now, if Good Trade has not run a simulation or has not run a batch size such as the one in our demo, they can utilize our simulation to not only verify our production time, which you can see 15.75 is underneath that rounded up 16 hours that we used on the calculator. More importantly, the simulation can calculate maximum estimated queues, which will help Good Trade with material handling and cold storage going forward. And with that, I would like to cheers to our team, cheers to you guys, and open the floor for some questions.
Question, you guys stated in your presentation you're rounding up your time.
Yeah.
Would you say that's, rounded up time can add up, right? So in what instance would you round up, and in what instance could you be more exact with a decimal time like that?
Yeah, so before, Good Trade was just using their own intuition and picking a price. And so while our estimation could be a lot closer with tolerances, we decided to leave it open to rounding and allow them to really take it where they want to going forward. Thank you. Yeah.
You mentioned a couple items in your first couple slides, but what were some of the unique items that you ran into working with a startup company as opposed to maybe a more established group?
Well, when we started, the pasteurizer wasn't even hooked up in the facility at all, so it wasn't even functionally running. Wasn't until, I don't remember the exact date, but it was more later into the fall we were actually able to do the testing. Along with that, it was a new piece of equipment, so there was a lot of trial and error within just the machine maintenance in general. We were still learning how to use it, we were learning how different things affect it, so we didn't always have a consistent availability to be able to do a lot of the testing on the pasteurizer. That was one very particular thing. Yeah, lack of data beforehand too. We had to create all of our data on our own. So a lot of other projects were able to pull from a data source that companies already had. We did not have that, so we really had to create it ourselves. A lot of our work was really around the pasteurizer aspect and then the analysis.
Thank you.